Good morning, students. So the first chapter which I'm going to consider to discuss the passing package is ray optics and optical instruments. Okay, as you all know about ray optics and optical instrument, I'll just briefly explain what is there in it, and then I'll move to the derivation part. Okay, so first, as you can see here, light rays and beams they have given, isn't it? Since in this lesson, at most of the parts, we learn about rays. So what do you mean by ray? And what is the difference between ray and beam? So ray is a straight line and with an arrow mark. If you have a straight line with an arrow mark, which shows the direction of light, okay, which shows the direction of light. What is the direction of light? Why do we need the direction of light? Because, so if I consider sun or earth, okay, so sunlight, they come to earth. This is a basic, right? So sunlight, they come to earth. Where is sun? Sun is at a place. Where is earth? Earth is at a place. So to show the direction of the light, which is coming from sun to earth, what do? We draw a straight line, and to show the direction, we put an arrow mark to it, right? A straight line with an arrow mark, single. A straight line with an arrow mark is nothing but a ray, okay, which shows the direction of light, which is traveling from one point to another, right? Basic. Now, what is a beam? So a set of such rays, not single one, okay? Such set of such rays is called as beam. For example, you can see here parallel beam, isn't it? Here we have 5 rays, right? What did I say? 5 rays, specific, isn't it? When I talk about the whole part, I call this as a beam because there are set of rays, isn't it? So that is the difference between a ray and a beam, okay? So there are 2 types of beam. One is divergent and the convergent. Divergent is when the light gets diverted from a particular point, okay? Convergent is when all the light rays, they focus at a point and meet at a point. That particular point is called as convergent. They are converging at a point, isn't it? They are meeting at a point. So that is converging beam. If they are diverging from a point, then if they are moving in different directions from a point, then we call it as divergent beam. Okay. So the next topic in the sense, there is a basic topic of ray optics and optical instruments, that is reflection of light, which was one of the important topic earlier. But now since they have deducted the portion, so they have removed the reflection of light. But to know about refraction of light, we need to have the knowledge of reflection of light. So what happens in case of reflection of light? In case of reflection of light, you will have only one medium. Okay, you will have only one medium. So ನಾವು ಕನ್ನಡಿಲಿ ನೋಡ್ತೀವಿ ನಮ್ಮ ಮುಖ ಅಲ್ವಾ, ನಮ್ಮ ಮುಖನ ನಾವು ಕನ್ನಡಿಲಿ ನೋಡ್ಬೇಕಿದ್ರೆ ಕನ್ನಡಿ ಮುಂದೆ ನಿಂತಾಗ ಕನ್ನಡಿ ಆ ಕಡೆ ಇರೋದ್ ಕಾಣತ್ತೋ ಅಥವಾ ನಮ್ಮ ಮುಖನೇ ನಮ್ಗೆ ಕಾಣತ್ತೋ? ನಮ್ಮ ಮುಖನೇ ನಾವು ಕಾಣತ್ತೆ, ಆಬ್ವಿಯಸ್ಲಿ ಅದನ್ನೇ ಹೇಳಿದೆ ನಾನು ಅಲ್ವಾ. ಸೊ what is happening in that mirror? In that mirror, the rays which are coming from my side, they are reflecting, they are bouncing back. Hence we are able to see our own image rather than seeing the other side of the mirror, isn't it? So that's what happens. Andre illi, when I talk about reflection, the bouncing back of light happens in the same medium. Ellinda incident ray bandidyo, reflected ray allige hogutte. Bandiruanta light ಆ ಸರ್ಫೇಸ್ ಗೆ ಹಿಟ್ ಆಗಿ it won't be able to pass through it. Why? Because a mirror which has got one side transparent, the other side opaque. Matton side opaque irodrinda, it won't allow the light to pass through it. So what happens to the light? Light, it comes and hits the boundary, hits the surface of the mirror, and it gets reflected. Okay, it gets reflected. When I talk about ball na ತಕೊಂಡು ನೀವು ಬಾಲಿಗೆ ಹೊತ್ತಾಕ್ದಾಗ ಏನಾಗುತ್ತೆ? ಬಾಲ್ ಆ ಕಡೆ ಹೋಗುತ್ತಾ? ಇಲ್ಲ, ಬಾಲ್ ಬೌನ್ಸ್ ಬ್ಯಾಕ್ ಆಗಿ ನಿಮ್ಮ ಹತ್ರನೇ ಬರುತ್ತೆ, isn't it? So that's the same condition. Okay, so ಅದನ್ನ ನಾವು ರಿಫ್ಲೆಕ್ಷನ್ ಅಂತ ಹೇಳಕ್ಕಾಗಲ್ಲ, ಬಿಕಾಸ್ ರಿಫ್ಲೆಕ್ಷನ್ ಹ್ಯಾಸ್ ಗಾಟ್ ಸರ್ಟನ್ ರೂಲ್ಸ್. Okay, it has got two rules. What are the two rules? The rules are incident ray, reflected ray, and normal. They should lie on the same plane. What is normal then? So normal anta ಹೇಳಿದ್ರೆ ಈ ಸರ್ಫೇಸ್ ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಏನಿರುತ್ತೋ ಅದಕ್ಕೆ ನಾವು ನಾರ್ಮಲ್ ಅಂತ ಕರಿತೀವಿ. So you might have heard about normal reaction in your first PUC classes. So that is the normal. Okay, normal is the perpendicular reaction to the surface. ಇವಾಗ ನಾನು ಇಲ್ಲಿ ಕೂತಿದ್ದೀನಿ ಅಂದ್ರೆ this is my normal, the thing which is perpendicular to me. Okay, so ಇವಾಗ ರೇಸ್ ಈ ರೀತಿ ಇನ್ಸಿಡೆಂಟ್ ಆಗಿದೆ ಅಂದಾಗ angle between incident ray ಮತ್ತೆ normal ray ಏನು ಇರಲ್ಲ, it will be 0. Similarly, what happens when a ray incidents along normal, the reflected ray will also be in normal. It also moves in the same path as of incident ray. In case the incident ray incidents on the surface obliquely. What do you mean by obliquely? By making an angle ante artha. Okay, so if incident ray is incidents on the surface by making an angle with the normal, the reflected ray also gets reflected by making an angle with the normal. So ಏನ್ angle incident ray normal ಜೊತೆ ಮಾಡುತ್ತೋ, ಏನ್ angle reflected ray normal ಜೊತೆ ಮಾಡುತ್ತೋ, the angles should be equal. That is the rule of the reflection. Only the phenomenon is called as reflection only if angle of incidence is equal to angle of reflection. Okay, so this is about reflection. So the main part which are we going to consider in this lesson is refraction. Reflection part is, I explained reflection just to make you understand the refraction part. Okay, that is the basic of refraction. So what happens in case of refraction? Reflection ali we had only one medium, because ellinda light incident ಆಗಿರುತ್ತೋ ಅಲ್ಲಿಗೆ ಬಂದು ಬೀಳುತ್ತೆ ರಿಫ್ಲೆಕ್ಟ್ ಆಗಿ ಅಲ್ವಾ. But in case of refraction, we'll have two or more media. Okay, there is no one medium here. So there will be two or more medium. Okay, so here is the diagram. You can see here, right? So this is one medium. Okay, this is one medium, and this is one more medium. Incident ray. What is this? This is normal. As I told you, normal is nothing but the perpendicular to the surface. It is a normal reaction which is perpendicular to the surface. Here we don't call it as surface, we call it as intermediate, because the light can pass through this intermediate. For example, glass. Now class ಅಲ್ಲಿ ಕೂತಾಗ ವಿಂಡೋ ಇಂದ ನಮಗೆ ಹೊರಗಡೆ ಲೈಟ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಕ್ಲಾಸ್ ಒಳಗೂ ಲೈಟ್ ಆಗತ್ತೆ. ಯಾಕಂತ ಹೇಳಿದ್ರೆ ನಮ್ ಸುತ್ತಮುತ್ತಲ ಪೂರ್ತಿ ಗ್ಲಾಸಿನ ವಿಂಡೋಸ್ ಇದೆ ಅಲ್ವಾ. ಗ್ಲಾಸ್ ಇನ್ ಥ್ರೂ ಲೈಟ್ ಏನಾಗುತ್ತೆ, ಪಾಸ್ ಆಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ hence you will have, hence the light passes through the window. Window in the sense, if it is glass window, only if it is glass window, the light will pass through it, right? So there are two medium ಆಯ್ತು ಅಲ್ಲಿ ಅಲ್ವಾ. So ಇಲ್ಲಿ ಇದೊಂದು medium, ಇಲ್ಲಿ ಮತ್ತೊಂದು medium. So incident ray incidents on the intermediate and it gets refracted. Refracted is the bending of light. Okay, this incident ray ಇಲ್ಲಿ ಏನು intermediate ಇಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ it would have gone like this, but now it is bending because the medium has changed from this to this, isn't it? Now my medium has changed, hence the velocity of the light will also change. That's why there is bending of light. Okay, so you might see here one more reflected ray. Ma'am, refraction ಆಗ್ಬೇಕಿದ್ರೆ reflected ray ಹೇಗ್ ಬಂತು ಮ್ಯಾಮ್ ಇಲ್ಲಿ ಅಂತ ಕೇಳ್ಬೋದು ನೀವು. Reflected ray ಇವಾಗ ನಾನು ಮತ್ತೊಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ. So when you stand in front of a glass, I'm not talking about mirror, when you stand in front of a glass, will you be able to see your image in the glass? Probably not clear agi, but nim image ಆ ಗ್ಲಾಸ್ ಅಲ್ಲಿ ಕಾಣುತ್ತೆ ಅಲ್ವಾ. What does that mean? ಆ ಗ್ಲಾಸಿನ ಥ್ರೂ ಲೈಟ್ ರಿಫ್ರಾಕ್ಟ್ ಕೂಡ ಆಗುತ್ತೆ, ರಿಫ್ಲೆಕ್ಟ್ ಕೂಡ ಆಗುತ್ತೆ, isn't it? So the incident ray which incidents on the intermediate, partly it gets refracted and partly it gets reflected. So this is the phenomenon of refraction. When the ray passes from one medium to another medium, there will be bending of light. Okay, So that bending of light is called as refraction. Okay, so here also it also has certain rules for it. Ella refraction, ella bending of light igu now refraction anta tekondu helak agadilla. Sarina? So ella phenomenon iga agate anta tekondu helidre adanna refraction anta tekondu helak agalla. There are certain rules for it. So again it has got two rules. One, similar to as of reflection. Incident ray, reflected ray, normal, they all lie on the same plane. Done? This is first law. Same as in reflection. Second law, what it says? The second law says sine of angle of incidence. Okay, sine of angle of incidence, the ratio of sine of angle of incidence to the sine of angle of refraction will always be equal to a constant. Okay, what is the second law? The ratio of sine of angle of incidence to the sine of angle of refraction is always equal to a constant. Okay, so why do we only consider sine here? Because the ray will always be in sinusoid. Sinusoidal wave ಆಗಿರೋದ್ರಿಂದ ಅದನ್ನ sine ಅಂತ ತಕೊಂಡೆ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಸರಿನಾ? And it is making an angle with normal. Okay, so that you need to know. ಆಯ್ತಾ? So it is equal to a constant ಅಂತ ತಕೊಂಡು ಹೇಳ್ತೀವಿ. ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನೋದು ಯಾವತ್ತೂ ಕಾನ್ಸ್ಟೆಂಟೇ ಆಗಿರತ್ತಾ? ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿರುತ್ತೆ, ಬಟ್ ದೇರ್ ವಿಲ್ ಆಲ್ವೇಸ್ ಬಿ ಚೇಂಜ್. ಓಕೆ, ಸೊ ಚೇಂಜ್ ಅಂತ ಹೇಳಿದ್ರೆ ವ್ಯಾಲ್ಯೂಸ್ ಅಲ್ಲಿ ವೇರಿಯೇಷನ್ ಇರುತ್ತಾ? ನೋ, ವ್ಯಾಲ್ಯೂಸ್ ಅಲ್ಲಿ ವೇರಿಯೇಷನ್ ಅಲ್ಲ. ಇವಾಗ ವೆನ್ ಐ ಟಾಕ್ ಅಬೌಟ್ ಅ ಪೇರ್ ಆಫ್ ಮೀಡಿಯಾ, ವಾಟ್ ಡಿಡ್ ಐ ಸೇ? ರಿಫ್ರಾಕ್ಷನ್ happens for one medium more than two medium, isn't it? Not for one medium, more than two medium, two or more. So two or more in the sense you will have either two or more than two medium, right? So andre two different media. Ivaga idu air medium andre idu water medium anta tekond consider madana. Air is not similar to water, water is not similar to air, right? Compare madadre water is a bit thicker compared to air, isn't it? So air medium alli yava speed alli light pass agutto ashte speed alli the light won't pass through water. Okay, the speed of the light, the velocity of the light will be decreased here in water. Okay, if I consider some other pair of media, if I consider air to glass medium, okay, so glass medium is different from water, glass is different from air medium. Again, glass is thicker than water, glass is thicker than air medium, isn't it? So when the light passes through air medium, the speed is different. When the light passes through, when it gets refracted through glass, again the speed of the light changes, isn't it? So ಎರಡು different medium ಅಂತ consider ಮಾಡಿದಾಗ speed of the light changes. Andre there should be a particular value for a particular medium. When I talk about a constant, that constant is nothing but the refractive index of that particular medium. So what do you mean by refractive index? Refractive index is nothing but the bending or the ability of light to bend in a particular medium. Okay, how much does that light bend in a particular medium is given by refractive index. If when I talk about water, water has got a particular value for refractive index, that is 1.33. When I talk about glass, glass has got its own value, that is 1.55. When I talk about air medium, right? When I talk about air medium has got 1 as the refractive index value, right? So when they say a constant ratio of sine of angle of incidence to the sine of refraction is equal to a constant, that constant is for a pair of media. If I consider 1 divided by 1 by 1.33, what is 1 divided by 1.33? The ray says it is traveling from water to air medium. Okay, ಅಥವಾ air ಇಂದ water medium ಗೆ ಹೋಗ್ತಾ ಇದೆ. This is a pair of media. This is the value constant. This value is constant. Why? Refractive index of water is constant, refractive index of air is constant. ಆಯ್ತಾ? So ಈ value ಇವಾಗ constant ಆಯ್ತು. If I change the pair of media, ಇವಾಗ light ಏರ್ ಮೀಡಿಯಂ ಇಂದ ಗ್ಲಾಸ್ ಮೀಡಿಯಂ ಹೋಗ್ತಾ ಇದೆ, ಅವಾಗ ಏನಾಗುತ್ತೆ 1/1.55 ಆಯ್ತು. ಕಾನ್ಸ್ಟೆಂಟ್ ಚೇಂಜ್ ಆಯ್ತಾ, ಆದ್ರೆ ರಿಫ್ರಾಕ್ಟಿವ್ ಇಂಡೆಕ್ಸ್ ವ್ಯಾಲ್ಯೂಸ್ ಡಸಂಟ್ ಚೇಂಜ್, right? Refractive index values, only pair of media is changing, so the constant values are changing, but the individual refractive index values, they are not changing, isn't it? So they are constants for a particular pair of media, right? The constant is for a particular pair of media, not at all the condition the value will be constant. It is constant for a particular pair of media. Okay, so the refractive index is given by, it is defined as the ratio of speed of light in vacuum to the velocity of light in any other medium. Okay, in any other medium. So this ratio gives you the value of refractive index of the medium. Okay, speed of light, which is constant, right, which doesn't change. 3 into 10 to the power of 8 meter per second is the speed of light, which doesn't change. Whereas the velocity of the light in a particular medium changes. If I consider water, it changes, right? If I consider glass, the velocity of light changes. If I consider diamond, the velocity of light changes. Why? Because air medium alli ಎಷ್ಟು obstacles ಇರುತ್ತೋ ಅಷ್ಟೇ obstacles water medium ಅಲ್ಲಿ ಇರಲ್ಲ, ಅಷ್ಟೇ obstacles glass medium ಅಲ್ಲಿ ಇರಲ್ಲ, ಅಷ್ಟೇ obstacles diamond ಅಲ್ಲಿ ಇರಲ್ಲ, right? So these are the different velocities of light in different media. Okay, whereas in case of vacuum or air, okay, the speed of light will never change, it will be same. Okay, so the ratio of speed of light to the velocity of light in a particular media is given by refractive index. It is also tells you the ability of light, how much does it bend in a particular medium, is given by refractive index. Okay, so here is a table. So here is a table which gives you the idea of refractive index of different media, right? So diamond has got 2.419 as the refractive index, and sodium chloride has got 1.54, water has got 1.33, benzene has got 1.5. 1.33 is water, 1.54 is sodium chloride, they are saying. 1.55 is glass. Okay, don't get confused. 1.55 is glass, 1.54 is sodium chloride, 1.50 is benzene. Okay, 1 is the refractive index of air medium. Okay, so here I wind up my class. So from the next class, I'm going to do the question and solutions, question and answers for different derivations and different definitions. Okay, so thank you.